Hello guys, and welcome to my channel. In today's video, I'm going to share with you what I actually worked on during my PhD. Okay, so it can be motivating to you so that you can have an idea into what I do. So during my PhD, which I did in Malaysia at University Technology Petronas, I was involved in a project that contributed towards solving flood problem in Malaysia. In Malaysia, there is frequency of flood occurrence within the cities. Okay, so what happens is that because of rapid urbanization, the roads or the soils are now completely paved. Okay, we have tarred roads, we have rooftops, and we have a lot of paved areas around the cities. So what happens is when rain falls, it quickly gets to the drain faster, and from the drain it quickly gets to the rivers faster, and that results in a lot of flooding or backwater. Okay, because the water gets to the river faster, there is no infiltration. The soil is no more being recharged as usual. So a lot of the water that is supposed to be seeped in the soil is now being transported faster into the river, and that has consequences, and that's flooding. Okay, so the government now thought about a technique, a technology that can help in mitigating this flood. And universities since Malaysia or USM brought in an idea of what they call bioecological drainage system. It's a system that promotes control at source. Okay, control as at the time the rain falls and when it falls. Exactly when it falls, the control will start at that point. And this bioecological drainage system or bioecots consists of different components. Okay, so there are the different artificial ponds and channels which they have constructed, they have proposed, and they made the university like a sample point. Okay, something like a test point. Okay, so they make the entire bioecosystem in that university. Now, one of the most interesting part of that system was just to create a connection between surface water and subsurface water. Okay, so that they can promote seepage. Okay, naturally. Now, one of the key areas that I have worked on is on developing a perforated drainage system. Okay, a drainage system that has link with the subsurface system. And what they use one component of the subsurface called the subsurface drainage modules. These are like the live wire connecting the surface and the subsurface system. So instead of you to have a normal drainage with concrete, okay, now we have drainage but with soil everywhere, and then we have some structures underneath that are porous in nature. When the soil now becomes saturated, then the water now starts storage inside that drive. Then when it gets enough potential energy, then it starts flowing down to the river. So the entire thing was to create sort of delay in the flow from the contemporary method of getting the water fast into the river to creating a delay through seepage, through storage, through some kind of movement within the perforated section of the drain to delay the water before getting to the river fast, and that helps a lot. So my work was to develop a numerical technique, mathematically, that I can verify and validate, do some experimental procedure to understand the behavior of the module, the subsurface drainage modules, and to validate in the field, and probably to develop a model that can be able to understand or give detailed behavior of what the flow between the solid structure and the fluid body, how they relate, and how does that affect the seepage, and how does that affect the overall flow or seepage level of that particular rain, the association with the soil, solid body, as well as the entire flow. So the hydraulics there, the parameters, there are a lot of parameters which we need to study to understand how effective is the pattern in terms of the storage. Does it store water? Does it allow too much seepage? You have to get it to optimally behave in the subsurface system so that we don't have too much storage and we don't have too much of the water running to the drain faster. So my work was on the numerical part. I used a software called Ph.D, okay, to develop the numerical models, and have validated a lot of the findings in the laboratory and in the field as well. So it was a fantastic experience because I could really barely understand the fluid solid body interactions, how the solid and the fluid interacted at very detailed level. I could see the reactions, I could see the flow parameters, I could ascertain everything that I have done in the laboratory. I was able to replicate same in the system after carrying out series of simulations. So when the validations become perfect, I now presented my results as a numerical technique that can study the behavior of subsurface drainage system even before you go on site to start constructing. You will be able to ascertain the behavior. You will understand how the module is going to behave when you take it to site, but numerically first. Okay, so that technique saves time, saves a lot of money, and saves you a lot because you don't have to go and start and construct first and test it. No, you have to do the numerical technique first, and once you ascertain, then you can go to the field. You can do all sort of adjustments until you get it perfect, you get the optimal dimension, and you get the optimal behavior, so you don't move to the field to carry out your construction in the site. So like I said, the BioEcon is a very big system with different components, but I work on the subsurface drainage modules components, and it was a very big addition and great addition to the project. So this is about my PhD. So you feel free to share what you are working on currently or what you have worked on during your PhD in the comment section. Thank you very much for watching, and I believe and hope you have learned something. Please let me know about your PhD, what you are working on also, so that I can feel much more connected to you. I'll see you in my next video. Bye.